Welcome to physics class, daily physics class. Every day I am having some conversation with two students. One is from Ivy League Brown. The youngest NYU student is 192 years study. Okay, so today, what did you do yesterday, folks? Can you remind me?
We studied the charge triangle, so we found the. Well, he's going to say he found everything.
So-
we found the electric.
What was the topic yesterday?
We found the electric field and the electric force at every point. So we were mostly dealing with static charges. So now we're dealing with lots of charges moving at once, which we call current inside a circuit. So I'm really excited to see what opportunities open up today. I'm really excited to be brilliant. This letters.
Be careful, he's coming up.
Yesterday we looked at an electrostatic charge distribution.
People, students only go to Harvard if they get rejected by Brown.
Harvard, right?
Yeah.
Okay.
Okay, so yesterday we looked at an electrostatic charge distribution that was a triangle, and we calculated the field and force at each charge.
All right, absolutely good. Let's start our conversation with something easy, and that is complex circuit.
Wait, something easy is complex?
Okay, so we start difficult and then we go easy. So voltage, let's say 20 volt, right? This is plus, this is minus. The definition of current, as you know, the current goes from positive terminal to negative terminal in a given amount of time without making any any accident. So let me give this one, the bulb number one. Let's call bulb number one 10 ohms. Everybody write it down. And then let's call bulb number two is 15 ohms. Bulb number two is 15 ohms. Let's call bulb number three is 2 ohms, right? And let's call bulb number four
This isn't complex, it's just a parallel.
Is four, or is, let's say, 6 ohms, right? And let's say bulb number 5 and 6.
Okay.
This called bulb number 5 is 3 ohms, and bulb number 6 is, let's say, bulb number 6 is 5 ohms. Now,
so it's like 60% parallel, 40%.
So this is neither parallel nor complex nor series. It is a complex circuit. Before I solve this problem, Raf, can you tell me which one is the brightest bulb?
No, because
No. Tell me which one is the brightest bulb.
Out of intuition, dummy sucker.
Yes.
Okay, well, if it was series.
Okay, all right. Which one? I gave you 6 bulb.
Yeah.
Okay.
Stupid.
I give you 6 bulb. Which one is the brightest?
Okay, I'll guess it's R2.
R2. Okay. This is chosen by Raf. Raf said R2. And Isaac from NYU.
Well, I'm going to say since P equals V squared.
Hold on, it's just intuition. If you have one.
I'm gonna
He
say.
doesn't know any physics.
I'm gonna say through the arcane magics that it's R3.
R3 is the brightest.
Wow.
Yes.
Okay, R3 is.
Wait, no, it's R1. Sorry.
R1 is the brightest.
Good choice.
Isaac.
Yeah, there's no reason to.
All right,
pick it.
this is one. The second brightest. Which one would be the second brightest? Raf. Brown, always come fast, not because it's alphabetical order, but it is Ivy League.
Second brightest.
Okay,
R1.
Second brightest is R1. All right, this is Raf. Isaac, second brightest.
She's just picking the highest resistances.
Isaac,
This
second
dumb
brightest.
No,
sheep.
it's a big strategy.
Isaac, second brightest.
I'm going to say it's R2.
R2 is the second brightest. Okay,
What is your
Isaac.
strategy? What do you mean?
All right.
Nothing.
Okay, let's
I'm
go.
just picking the opposite.
Let's go. All right. So here Isaac 1. All right. Here Isaac 1. R1 is the
What?
brightest. And here nobody won. All right. In fact,
You
R4 is the second brightest. Okay. How do you know? Okay, that's why they invented math, to verify. Okay, let's do it. We're gonna convert it to the. We're gonna call diagram number 1, diagram number 2. Let's convert it to diagram number 2. This is 20 volt, right? And
Yeah.
this is how much?
10.
10 volt. R1 is 10 volt. And this is, Isaac, can you add this too?
We're in a parallel, so wait, no, that's a series, isn't it? So that means it's just gonna be 17.
Good. So this is R is 17 ohms. So please don't do that. Okay, in the physics class we don't do that.
Why?
Okay, because your teacher says so. All right,
I
so
love you too, Dad.
R is 6 ohms. And what is this one? Isaac, you are good in adding
1.8.
things because
1.8.
15 plus 2 is 17. So 3 plus 5 is 8. Is that right, Isaac?
No, it's 1.86.
Okay, so 1.9.
1.875.
Oh, you little.
1.9 it is. Stop respecting each other. Okay.
Respecting. I
Yeah.
love you too.
Okay, all right. This is rectangle number 3, right? In rectangle number 3, we have 20 volt, of course, and you have how much? 10 ohms, and then R1 is 10 ohms, and then what do you have?
Volts by mistake.
Oh, yeah, this is must be ohms, and this is 17, right?
Yeah.
R is 17 ohms, and then can you add this?
Yeah, 7.9.
7.9. So this
Genius
is
figures out how to add 6 to
7.9 ohms. Now, diagram number 4, if we can show that, yeah, sure. Diagram number 4, Isaac, can you please pay attention?
What do you think I'm doing?
This is 20 volt, and this is 10 ohms, and this is how much?
5.4.
Is this 5.4?
Yeah, 5.4.
So this is 5.4 ohms, right?
Yeah.
5.4 ohms.
Then you just
5.4.
add them one more time to get 15.
So last diagram number 5, I have a rectangle which is circuit, and this is 20 volt, and this is how much ohms?
15.4.
15.4, is that right?
Yeah.
15.4 ohms. Now, I'm going to ask, you cannot answer the question unless you're being asked. Isaac, can you tell me how much voltage consumed by this bulb?
Let me see. So isn't it just going to be 20 volts?
That's correct. So 20 volt. Raf, can you tell me what is the current flowing over here?
Yeah, 1.3.
1.3.
Amps.
The current is voltage divided by
Resistance.
So 1.3 amps. You must include the SI unit. If you don't, then you lose. And it seems like the NYU gonna lose to Brown.
Oh, come on. But I got that one right.
That's 1 point only.
So he gets 0.
Oh no, he earned some point.
Oh, he
Okay.
earned some points by just beep pooping into a calculator.
Okay, no. Okay, so Raf and Isaac. Raf has 3 points. Isaac has 1 point.
Wait, what? Where'd he get 3 points from?
Raf has probably 2 points.
This is illegal.
Okay, 1-1. Okay, 1-1. All right. So now, what do you think this 15.4 come from, Isaac?
From adding. Oh.
Yeah.
From adding the resistance?
Raf.
From adding the resistance.
What type of relationship they are in? Series. Okay. How many information you have?
Right.
3 information. Which one you are allowed to use?
The current.
Why is that?
It's
the
a
current
series.
is the same.
Okay, good. So
Count, guy, count.
1.3 amps and 1.3
3.
amps. Isaac, can you tell me quickly the voltage here and the voltage here?
All right. So the 13 and 7.02.
So 13. Make sure you have to say volt. Otherwise, you're gonna lose point.
I see.
Your score is now 0.
What?
Okay. All right. I want to be generous. I want to give you 1.1, 1.2.
Wait, no. Dad.
Yes.
You remember Run Forest Run?
Yeah.
Now we have calculate. Reverse calculate.
All right. So what is the voltage over here? No, the voltage should be you multiply this and this.
It's 7.02.
7.02.
Yeah.
Can I trust him?
Yeah, I got the same.
All right.
No, man, don't trust me.
All right,
You
good.
have to do something.
Now look. You're done with this one because this one is how much?
13 volts.
13 volt, and this one is how much current flowing here? 1.3 amps, right?
Yes.
Okay. You done with diagram 5? You even done with diagram 4? Now I have a question for Isaac.
I'm gonna
Isaac,
say that the voltage is the same.
Isaac, can you tell me where does 5.4 come from?
Adding 17 and 7.9.
17 and 7.9 are in what type of relationship?
Parallel.
parallel. If it is parallel, which information the ohms, that guy ohms allow you to use?
Probably volt.
The volt. Okay, so how much voltage over here?
7 and 7.
7 volt and 7 volt. Okay, so Raf, you're gonna give me the current.
Okay, so current for the first one is 0.41 amps.
0.41 amps.
And for the second one, 0.88 amps.
0.88
Amps.
amps. Okay, Isaac, back to you, baby. Can you tell me where? Oh, by the way, Isaac, can you quickly tell me how much voltage here?
That's still 7.
How much current here?
0.41.
All right, Isaac, can you tell me where does 7.9 come from?
Adding 6 and 1.9.
6 and 1.9 are in what type of relationship?
Serious.
The dead guy ohms allow you to use what color if it is in series?
I'm going to say it's blue. I mean pink.
What?
All right, so 88, 0.88 amps and 0.88 amps. Albert, can you, or Ref, can you tell me the voltage?
Calculate. We have to calculate.
5.28 volts and 1.67 volts.
1.67 volt.
Yeah.
We are done with 3. In fact, we are kind of done with 2. So we're gonna
Thank
go
you,
back
Raf.
now. Raf, can you tell me where does 17 come from?
Adding resistors 2 and 3.
What are they are in what type of relationship?
Series.
What information that guy ohms allow us to use?
The current.
Current. How much is the current?
0.41.
0.41 amps and 0.41 amps. Isaac, can you tell me the voltage?
Wait, what? Oh,
Yeah,
I'm supposed to multiply them, right?
I think
No,
so.
Divide them.
But Forrest Gump can do it better than I can, you know?
Yeah, go ahead.
It's 6.15 for the top one and 0.82 for the bottom.
6.15.
Apples or oranges?
Oh my god,
Yes.
Forrest Gump.
Yeah.
I mean,
What is
Raf
this
Gump.
one? Raf, Isaac?
0.82 volt.
Volt. Okay.
Actually, no, it's 0.82 bananas.
All right. Good. And Raf, okay, Isaac lost 0.1 point
Oh, why?
because you kind of respected Raf less.
Can I do it more?
Yeah. Okay. So how much over here? How much current flowing over here?
Oh, same.
And how much voltage?
5.28 volts.
Oh, I know what R and I stand for.
Isaac,
That's
can,
not Refat and Isaac. That's resistance and current.
Isaac, can you tell me 1.9 come from?
Adding 3 and 5.
3 and 5 are in what relationship?
Parallel.
So which information that guy ohms want you to use?
Probably the volt.
Okay, why is that?
Because the voltage will be the same for both.
Good. So, Raf, can you tell me the current, please?
Calculate, Refat.
0.55 amps for the first one.
0.55 amps.
And 1.67 over 5. 0.33 amps.
0.33 amps. Okay, now what are you going to do? We're going to do, now put them together. Can you guess what you're going to do? Voltage, and then
Current.
VI, and then
Resistance.
R, and then
Power.
power. Okay, 1, 2, 3, 4, 5, 6, and total. Okay, whose column Isaac want to do?
I'm going to do the resistance.
Go do the resistance.
Okay, so R1 is obviously 10. R2 is 50. Wait, this is the easiest one. R3 is 2.
Okay, go ahead.
R3 is 2. R4 is 6. R5 is 3. And R6 is 5.
How much altogether?
So altogether, it's 15.4.
Raf, which column you want to do?
Current.
Go, please.
R1 is 1.3.
Mm-hmm.
R2 is 0.41. R3 0.41. R4 0.88
Mm-hmm.
amps. R5 0.55. R6 0.33. And total is 1.3 amps.
Let's see whether Isaac understand it is 1.3. So Isaac, can you tell me 0.41 plus 0.41 is how much?
0.41.
Good, he passed that test. Isaac, can you tell me 0.55 plus 0.33 is how much?
Pi. No, I'm just kidding. 0.88.
Good, he passed that test as well. Isaac, can you tell me 0.88 plus 0.88?
It's E. I mean, it's 0.88.
That's he passed that one. Isaac, can you tell me 0.88, the 0.88, and then this 0.41?
I give up. It's 1.289.
Okay, can you tell me 1.3 plus 1.3?
2.9. Just kidding. It's 1.3.
Good. So that's how we got
I
1.3.
can see the smile fading from your face when I said 2.6.
Oh, well, because who want to see NYU winning?
Yeah.
Nobody. Okay, voltage.
Okay, I'll do voltage.
Did you by any way disrespect him?
No, I
No?
respected him as much as possible.
If you don't respect Ivy League, you will never get into Ivy League. That's the
I don't really care. I don't really care, man.
okay. All right. Who
I don't care.
when you see Ivy League, you have to say go ahead. So voltage.
Okay, voltage. V1 13 volts.
V1 13 volt.
V2 6.15. 0.82.
0.82.
5.28.
5.28.
1.67.
1.67.
1.67.
0.67.
And 20 volts.
Okay, I'm gonna test Isaac. Isaac, voltage. Can you tell me 6.15 plus 8.82?
Huh? Oh, 6.15 plus 0.82 is
Without joking, this is not. People have to understand it.
Is it 7?
Okay, it is okay. Good, I take that. Can you tell me 1.67 plus 1.67?
1.67.
1.67 plus 5.28.
Probably 7.
7 plus 7.
13. Wait. 7.
Did he mess it up?
Yeah, 7.
7.
Yeah.
And 7 plus 13?
No, it's 15.
No,
Okay.
I'm kidding.
No, I mean we understand you're kidding, but let's be serious. Ref, let's do it. 6.15 plus 0.82.
6.15 plus 0.82 is 7.
Okay, good. 7. 1.67 plus 1.67. 1.67 plus 5.26. 7. 7 plus 7.
14.
7. Because that's gonna be parallel.
What a stupid.
7. 7 plus 13. 20.
Not
Okay, good.
worthy of the Ivy League.
All right.
Maybe
Okay.
to publish 2 papers, but
Howard.
you get 2 reading physics.
That's made him human. Do you understand the definition
Nah,
of
man,
human?
that makes him stupid.
Ask me 3 plus 2.
What's 3 plus 2?
4. That's make me human.
No, that makes you illiterate.
Jesus. Okay, power.
Okay.
I'm pretty sure it's V squared over R.
Oh, well, VI is better than V squared over I.
Oh.
Only NYU take this route. The Brown will take, okay, VI. It
13
takes
times 1.3 is 16.9.
16.9.
6.15.
what? Atoms? Joules?
I am going to.
Mars, okay.
I'm going to disrespect Braille.
Okay. You never disrespect Ivy League. If you do disrespect Ivy League, guess
That
what?
one is 2.52.
You're never gonna go to Ivy League.
I don't care.
Okay.
Okay, that one is 2.52.
2.52.
2.52 watts, so you don't say anything.
That was also disrespect.
Do you care anymore?
You disrespect Rap, that's fine. But he put on Brown.
Oh, sorry. Then I should have targeted the shirt instead.
Okay, all right. Next.
0.82. Calculate, Forrest Gump. Calculate. 0.34.
33.
0.33.
Yeah.
All right.
Come on. At least Forrest Gump can run faster than all the other kids. You can't even calculate faster than me.
5.28 times 0.88.
4.64.
4.64
watt.
Yes, repass Gump.
watt. Okay.
I love
1.67 times 0.55.
It's 0.9185. 92.
Okay. I can process only 2 digits. Sorry.
It's
0.55.
0.55.
Huh?
0.55.
0.55.
And the last one is 26.
Okay, we don't care about last one. We anybody can do that. Okay, let's see our hypothesis. Isaac said whose bulb would be brightest.
Wow.
Is that right?
Yes.
Okay, so Isaac get
Long shot.
0.1 mark.
You we got almost the smallest
Um,
one, like the
and Rap said, which one gonna be brighter?
I should have chosen 10.
So, okay, can you now, knowing the math and Ohm's law, can you tell me why the number 1 brightest, and you're gonna come and you're gonna explain why number 4 is brightest? Which one do you want to explain, Isaac? 1 or 4?
1.
Okay, come over here. Explain why the 1 is brightest. Now, knowing what you know now, make sure you don't disrespect important. All right, go ahead.
I love flumping him in the face.
What are you gonna explain?
Why 1 is the brightest?
Yes.
So 1 is the brightest because it has the most power. The end. No, I'm just
That's like
the sky is blue because it reflects blue light. The end. Okay. So it's the brightest because it has the most power, and that comes from having.
on, man. That's not I thought you were joking.
I thought too. Now he is buying the time. He's buying the time to figure it out.
I don't
You
even.
have no idea what is going on.
Nope. It survived the longest.
Okay, go back.
Okay, let me explain.
We understand.
I can explain.
We understand. Okay.
Don't let me explain again.
Okay.
So this people going to try to explain.
Do you
Yeah.
call him an expert?
Okay.
Don't read the
So
Yeah.
let me just take
2,
one. Okay.
1. Hiroshima.
It combines
Oh.
2 principles. So in a
We are talking about principles. Pay some respect. Probably next thing he's gonna talk about principles.
so okay. So if you
Then I
have
disrespect Columbia.
okay.
Columbia is not Ivy League.
What?
Is it?
That?
Oh, okay, probably.
Okay, these are visible, right?
Yeah.
Okay, so if you have a parallel circuit and if you have a series circuit, right? Let's say they have the same battery, same voltage. So the power you can in the
Are you really explaining?
yeah in the series circuit, what is the same, the current or the voltage?
It's
voltage.
the resistance.
Voltage.
The
The
voltage.
resistance.
So V.
Okay.
Right?
He's
So-
also buying the time, but let's see.
Right. So here is the power for the
By time.
parallel
Don't.
circuit,
By time.
and for the series circuit, what's the same, the current or the current, right? So it's better to use P is I squared R, right? Is that what it is? P is IV by I squared R.
yeah.
Okay, very good. So now you can see which one is gonna deliver the bigger power. So let's see. If the resistance is bigger here, it's gonna give you a less power. So what you want is the smaller resistor here.
Sure.
So in the parallel, this is the parallel. The
We
smaller
already understand
resistor,
that parallel is small resistance give you the
Big power.
brightness.
Let him buy time.
yeah, and this is for parallel. And here is the opposite, right? Because it's
Yeah.
proportional.
I thought
So
we learned that
big
before.
What bull
Uh,
crap is he
gives
spouting
you big
now?
power.
He's struggling. He's
Now-
struggling.
Let's look at this step by step, okay?
I thought you said I was joking. Now you're
So-
saying it has
No,
big
no.
P because it has big R.
No. Let's see. So
Also,
let's
if-
start with no.
if
Can I
big-
finish?
If big R is big P, why is R2 the brightest?
Because let me finish. It's a complex circuit.
All right.
Yeah.
Okay.
Okay.
He's begging for
So let's start with this one. Here at this stage, the circuit is series or parallel?
series.
Just series, right?
Yeah.
So for a series circuit, the big resistor should have the bigger power. Let's see. So far, this is the bigger resistor. It should have more power, right?
Yes, yeah.
Okay. So far, this is the one with the most power. Okay.
Right.
Now here, let's see. Now we have 2 parallels. Okay. So out of these parallels, the smaller resistor will get the more power, right?
Why we do it 1.3 over here? It's not 1.3, is it?
It
Yeah,
is because
it is.
it's a series. So
Okay.
starting
1.3,
from 1.3.
Okay, yeah.
Yeah. So okay, here at this stage it's a series circuit, so the bigger resistor gets the more power, right? Okay, now at the next stage we have a parallel, right? So for the parallel circuit, this part of the parallel circuit will get more power than this resistor, but we still don't know how that compares with this one. Okay. Right? So we have to compare these two, but for now we know that just looking at the parallel one, this one is the biggest one out of the parallel circuit because the smaller resistance gives you the bigger power. So far this is the biggest one for the series. Okay, so now let's jump one more level. Okay, still this one is the big one from the original, but this one, it now we have another series, right? And in the series we know
Big means bright.
Big means bright. So in the series, let's see, this one is bigger, right? So this should be the bigger one, bigger power out of those two. Okay, and then we jump one more. Let's see. So this one is still one of the big ones from originally, and this one, let's see. So
You are using math to support you.
yeah, because otherwise there is no easy
I
way
wasn't paying
to.
attention. What was you
Okay.
talking about?
And this one is separated into a parallel, and in the parallel one, the small resistance
No one knows
gives
what
you-
he's talking about.
No, I understand, but he's
Okay.
using math.
R5.
He's using math.
Okay, so yeah, so you really just have to compare. So
So you really just
this
have
one-
to compare.
these are your three candidates for the big resistance.
Okay.
These are your three candidates: R1, R4, and R5. How did I get those three candidates? Because I compared it step by step. For example,
Okay, now,
Okay,
your
comparison
hold
is
on,
both sides.
hold on.
yeah.
Why this is also in series, right? This is bigger than 10. Why this is not brightest as you thought it is?
Oh, yeah, I forgot. So this is also broken up. So this is also in series. So I guess that's also a candidate for big. Hey, you don't know before you plug in, but
Okay, poopy fart.
Isaac, sometimes we draw the
Let's
line
see.
and we did.
so let's see. So the reason why is this has a big resistance, but it also has a big voltage, and power is V square over R. So even though it has a big resistance, it has a big voltage,
This is good.
which is good, but it also has a big resistance here.
Don't
Yeah.
even
It's
try,
not good.
Refast.
Okay, big resistance, right?
So, but here you have a
Take
small
him off and
voltage.
beat him.
So Isaac, do you have a
Okay.
better way
Yeah.
of explaining why?
No, but
No, just come try it together. When you cannot, what do? You just
give up.
no, you don't. You give up. That's not a good thing.
I talked about perseverance in India 5 years ago. It's been 5 years. I think we can give up now.
No. Talk. You want to come back tomorrow to kind of explain this, right?
Yeah,
You wanna-
probably.
Yeah.
Think out through
Yeah.
why although the candidate is 15 ohms to be
Mhm.
brightest, which you rightfully thought,
Yeah.
why the 10 ohms is the brightest and
Mhm.
why the 6 ohm is the second brightest.
Mhm.
Okay. Okay. All right. So let's conclude the day. Tell the audience what you learned and what you wanted to learn, but kind of what you gonna kind of take away from this to further discover. Go ahead. Yeah.
Okay. So what I learned is that biggest is not always brightest, even in a complex circuit.
Well, no, the
So-
series biggest is brightest, parallel the smallest is brightest,
Yeah.
but in complex is
It's
tricky
mixed.
business.
Yeah, you cannot guess from that, or at least not from what I know. You cannot guess from the beginning.
Well, if in
Okay.
What
Now
the-
hold on. The one mic at a time.
okay, if in parallel
No, look at the mic.
if in parallel smallest is brightest, we must be in a parallel circuit. Okay, but
Since this is complex,
so So
What would be the no? What would be the easiest way to find out rather than kind of guessing which one would be right?
do the calculations.
Well, do the calculation, but sometimes you have to guess. If you do have to guess, how you can use your intuition to guess? No, don't do that.
How?
How can you justify that this is the brightest and this is the second brightest?
How?
Without doing the math.
Oh, I have an idea.
No.
No, I just had an idea. One thing you can immediately see. Okay. Can I take the mic for 1 second? So one thing you can see is before the circuit gets too complicated, for example, these two series, they used to be, if you combine them, they're these two parallel combine into this, and these two series combine into this, right? Just starting from this one, you can begin calculating the power from here, and see which one gives you the bigger power. So what I mean, for example, what do I mean?
But when you guess, you are not here, you are here.
Yeah, but right now what we did is we calculated the VIR for each one, and then we calculated the power for each one, and then we compared. But but it could be you can calculate the power from an earlier stage and
No,
then
no, no.
compare.
You are not allowed to use all the math. You just allowed to look at this diagram number one, and make a guess.
Oh no, I don't think this.
Okay, so is this a good research for tomorrow?
Yeah.
So we're gonna be talking about it tomorrow. So let's end the conversation today.
Learn nothing, and I'm